Yes, how are we? Hey everyone, good evening. This is Kevin. I believe I'm your trainer for this particular CCNA session. I think most of you have been there for our demo session. I can see some familiar names. I think that was like a couple of days before, Wednesday or Tuesday.
Yes, 16th.
16th, yes. Great to see you all here. I actually know like we have 20 or 25 students for this session. Probably some of you are not available. I believe they'll be able to watch the recording anyway. No worries. Anyway, thanks for joining in. So, we are going to start with the basics today right away since this is just a 1 hour session. We won't be going into like too much of an introduction or anything over here. That part we have a lot of time, like 40 or 45 hours will be together for this particular session. Whenever you have any doubt, you can just come up. We'll discuss the doubts. During that time, we'll get introduced. That's- Okay, great. So a couple of things I just wanna like come up and say at the beginning of the session itself. First thing, always do try to make sure you guys do join in by 8 o'clock. The reason is, as I mentioned before, we only have 1 hour per day. So I will try to start all the sessions exactly at 8 so that we get like most of the time for this particular session. Second thing is, whenever you are having any doubts, I'm happy to help. Feel free to ask during our session itself. And my recommendation is if you have any doubts regarding the topic that we're discussing, directly go ahead and ask it at that particular moment. If you have any doubt that is completely irrelevant to the topic that we're discussing at that moment, please try to ask that like towards the end of the session or before we start the session. These two timings would be fine. Okay. I'll not close down the session before like confirming with all of you that you don't have anything more to ask. So no worries on that. Okay. So just want to let you know that beforehand itself. Okay. Great. I think that's it from my side. So before starting, if anybody want to ask something, feel free to ask. If not, we'll jump ahead and start the session.
Hi Kevin, Raghavan here. I just have a small doubt. This is my first session today, so did I miss something? As you said
Not
that.
much. This is our day one for the session, like CCNA session.
Okay,
Only thing that we did before was like a like demo session where I explained about like how what exactly is CCNA, how you can go through the different tracks of CCNA and all those kind of stuff. You should be able to
okay,
find a recording of that.
okay. Thanks a lot.
Sure.
Hi, Kevin. This is Charan.
Hi, Sharon.
Recording section where we can see.
You should be able to get that on your portal. Are you given the access to the portal?
No, I don't have any link. Can you share the link here?
I won't be having that. You'll have to check with the salesperson that you contacted. He will be providing you with the updated portal, your user
Hmm.
ID and password. Without user ID and password, you won't be able to access. That's why.
They will be creating a store for a single user password.
They will be creating a user ID and password for you and will share that to you. You can change it later.
Okay.
You have a registered email ID, right? In
Ah,
most
yeah,
cases,
yeah.
that will be your username and they'll provide you a
Hmm.
default password. Please check with
Hmm.
them. If you haven't received the user ID and password, please feel free to check with the team, like who
Okay,
you
sure.
contacted for the session. They will be
Okay, sure, Kevin.
okay. Right. So I
Sir,
guess I'm sorry.
hi sir, this is Bhubalan. I am newly joined. Today, I think first session, correct?
Yeah, today is our first session, right?
Thank you.
No worries. Okay. So I guess we can go ahead and start with our topics. In case if you are not able to hear me, please do tell me, okay? Sometimes if the net connection is problematic, that could happen. That's why. Okay, so let's go ahead and start with the session. So first of all, we'll learn or get to know something about what exactly is networks, because obviously this entire thing is going to be like running around networks.
बैग
So
से वो हेडफोन देगा मेरे को प्लीज। वो देखो तेरे,
I'm,
वो देखो ब्लैक बैग
I'm
मेरा। वो नहीं, ईयरपॉड्स नहीं, हेडफोन्स रहता है वो।
okay. 1 second, guys. Another thing, please be on mute. Like if you have any question, you can come ahead. If not, please be on mute. Okay. Thank you. So I'll share my screen and let's go ahead. Screen. Okay, there we go. I hope all of you. Guys, please be on mute. Again, once the session is started, okay, let's go ahead. So as you can see, this is our day one. This is our first session on CCNA. So over here, when it comes to the CCNA, like the beginning course, we will be following CCNA version 2.1, which is actually the most latest update that has been made by Cisco. And here we are going to learn about how to install, operate, configure, and even verify a basic IPv4, as well as a little bit about IPv6 networks. We will also learn about how to configure network components like switches, routers, mainly these two, but also wireless LAN controllers, how you can manage network devices like servers, NTP servers, etc. And we'll also identify, like, get to know a little bit more about what are the different kinds of security threats that you have on a network. All these kind of things we will learn in this particular session. And based on version 2.1, 2.1, you will be prepared for the exam, that is CCNA 200-301. This is your exam code. So whenever you're after our session, when you're going to purchase the exam voucher, it should be for CCNA version 200 to 301. And the current exam version is version 1.1. You will be prepared for this plus version 2.0 and version 2.1 based on the content that we will be taking over here. Okay. Even though the course is updated, exam we are still going for is version 1.1. Okay. So yes, let's go ahead. And once again, for the lab purposes, I would require you guys to download a packet tracer, like Cisco's packet tracer. It's a completely free software. I will provide you the link for that right after the session. I have already provided this during our demo session, but I can see like few of the students are new. So I'll provide that link once again inside this particular chat after our session today's. Okay. So yes, now let's go ahead and start. So step one, or question one that you have to ask in CCN is, what is a computer network? What is a computer network? Or what is a network? So the term network, this is mainly used in a lot of different aspects. Like it's used in a lot of different aspects. So some examples of networks, you can say social networks. It is a network. Then you have phone networks where you use to communicate with others. Then you have television networks. Then like one of the most commonly used word now in the tech area is neural networks, where it helps for machine language, chat GPT, like AI and all those kind of stuff. Similarly, the one we are looking into is computer networks. So whatever network it be, the basic concept of a network is like a system of connected elements that operate together. Okay, the terms are any, like a system, a network is basically a system of connected elements that operate together. So if you are considering the concept of what we mentioned earlier, phone networks, it's like multiple phone devices connected together so that they are able to communicate with each other. Same thing, social network, your Facebook, Instagram, everything. You have different elements. Here, the elements are people. People are connected together through your phones. If it's in Instagram, you have an application over there, you are able to communicate with each other through that. Right. So it's basically enabling communication between multiple items, devices, or people. And when it comes to this computer network, what's happening there? We are having our computers, we are having our devices. It can be computer, mobile phone, smartphone, whatever it is. So basically, what it does, it helps us to connect these devices together to form a system which is able to perform or work in harmony. Okay. So if I want to send something to one of you, what I can do, I can open my mail, type your mail ID, enter the details and send it. So based on that mail address, the data will be delivered to you. Okay. Internet, it is a network. This is done through internet. Hence, that's a network. So basically, a computer network connects devices that allows them to exchange data with each other. This facilitates information sharing, resource sharing, any kind of data sharing. Okay. So if you're considering like an example at your home, computers basically allow like the family members to share files like photos, or if you have like a Wi-Fi printer or something like that, you can print it using Wi-Fi, or let's say if your TV has Wi-Fi, using that particular network, you are able to watch movies or something else. Like if you want to, how to say this, like share your screen to that. Casting, yes. The concept of that is also networking. So when I'm talking about networking, it's not just about Wi-Fi or internet. Like even if you're having two devices, like two phones connected with each other using Bluetooth, that is a network. You have two devices connected together, sharing data. That can be considered as a network. So any devices or any system that communicates with each other through any particular connection can be considered as a network. Okay, we clear about the basic concepts of network, like what this network is. Okay, I'll take that as a yes. So when it comes to the enterprise or business environment, you have many operations like marketing, sales, IT, etc. So you have to develop applications that allow this particular information to be collected and processed, right? Like you will have different departments in a particular company. Let's call it, you have IT, you have sales and marketing, and you might have to share data between each of them, right? So for these kind of requirements and all, you will have to make sure there is some form of data sharing method enabled over there. Either they can share data between each other, kind of like peer to peer. Peer to peer means sharing data directly between devices, or you have an option to like set up a client server model. You have a server here, and each of them will be client one, client two, client three, and they will share the data with the server, and they will be able to take the data from that server itself. Like IT shares it over here, and marketing can take that data from IT and then use it. Okay, in such way, you will be able to make use or set up your network in whichever method that you need. All of this completely depends upon your business intent. Okay, so this infrastructure allows a business to run and lets even customers connect to that particular business using online stores or through like a third party or something like that. So, and this allows business to sell its products or services or any kind of action that it wants to do. So, allowing communication is basically what allows any kind of actual action to take place or actual transaction to take place when it comes to uh, like networking. Second. So, when it comes to like the concept of Cisco, the major things that we'll be noting down in a network are a few of the elements that you have over here. So this will include like what are the different parts of it, like routers, switches, all those kind of stuff. So before jumping into that, we also need to know what exactly are the common usages of network or common requirements of a computer networks. Usage of network. I hope I'm audible to all of you. Can
Yes, sir.
someone give?
Yeah, Kevin. Sorry.
No worries. Just wanted to check. Okay. So coming back, some common usages of network, please. So there are multiple types of communication depending upon who the participants are to enable this kind of network. So this can be like communication between human beings. For example, you can have two people communicating with each other over chat, like WhatsApp or something like that. So that is one form of networking, like allowing communication inside your network. And another thing you can assume communication between network machines. For example, imagine that you have like a alarm, fire alarm. Okay, automatic fire alarm. So it will be able to gather data inside a particular area and take that data and forward it to a server so that it will be able to identify whether there is an issue that could happen in the future. Or another example is humidity sensor. This is something that you commonly use inside knock rooms, like data centers and all. You have this humidity sensor to make sure that there is not too much like humidity inside that particular data center. Because if there is, it could result in sparks and servers or something like that getting damaged. Okay, so these are some of the examples. So one is person to person, then device to device. So this can also be communication between like server to server, whether like you have some data on a server. Somebody is using the whiteboard. Please do not. Second, I'll have to. Please hold on. Just give me 1 second. Kind of hard to like clear that line. That's right. Sorry about that. So imagine that you have a server one and you have a server two, which you can assume it as a backup server. So whatever data, whatever changes that you make in a network takes place inside this server. And maybe towards the end of a working day, what happens? This server takes a snapshot and sends all its data to server two to have it as a backup. So these kind of communication, a server to server kind of a communication, can be assumed as a device to device communication. Then there are communication between person to device and vice versa, device to person. Humans and machines. For example, let's say if you want to buy something on Amazon or purchase a movie ticket, you're not talking to people, you are not sending anything to any person. Instead, what you're doing, you're purchasing these things from the device, right? You're talking to an application or you're talking to a like website. You, for example, if you're on Book My Show or something like that, you open Book My Show, you select theater, you select the movie, you go to seats, you select it and pay it over there. So the communication that's happening there is between a person and a device on your end. Okay. So these are the different types of network communication that takes somebody having it out. Okay,
Hey, Kevin, I have one doubt.
go
Uh,
ahead.
can you can you come back again to what is mean by computer network? You are explaining how network. What is mean by computer network? Can you explain once again?
Computer network. No worries.
Yeah.
Sure. Okay, so computer network, the concept is having or allowing communication between multiple devices or multiple instances or any kind of aspects so that you're able to exchange data. So if you have a system which is able to communicate between multiple elements of itself, that you can assume it as a network, not just computer network, but a network. When it comes to computer network, the concept is that you are having like multiple devices that includes computers, routers, switches, etc. All of them being able to communicate with each other. So when it comes to networking, the only thing that you'll have to remember is the concept of communication. So for example, if you want to say one of the smallest networks is something called a peer-to-peer to peer communication, which means you have two devices which is able to communicate with each other. Okay, so imagine that you like took a photo and you want to share that particular photo to one of your friends. So nowadays, a peer-to-peer communication to send data between multiple devices, there are a lot of ways. Like sometimes you guys just forward it on like WhatsApp or Telegram, Viber, etc. So these are applications that you have, which is taking it from a third party. But imagine that you don't want to share this data with any like third party applications. You just want to share the data from your system to that particular system, the next person's system. So there what you have is you have to use the services which are present inside those devices and only that. No external services. You have two options. One is Wi-Fi, the other one is Bluetooth. These two are the options that you have right now because these are the only methods or only communication items that you have on your like smartphone. If you're using Bluetooth, it's fine. You will be able to share files using Bluetooth. All you have to do is like connect your mobile mob 1 to mob 2 and then forward the data. So if you're considering Bluetooth, what happens? This is acting as a peer. This is acting as a peer. And you will send a request asking to pair. So it will ask for a number. A number will be shown over on the first device 1, 2, 3, 4. This guy will type in 1, 2, 3, 4. And what happens? Both the devices are paired. Once it's paired, you can send the image from here to here. That is one option when you're using Bluetooth. Second one is something by using Wi-Fi. For this particular thing, you have something called Wi-Fi Direct available inside your smartphones. Most people don't use this, but it is a facility available in almost all the phones. So here what happens, just like Bluetooth, you'll try to enable connection from mobile 1 to mobile 2 and establish connection. But here the difference is only one person will be able to like enable communication. Hence it act as a like client server model. Okay. So if he want to send connection to here, he should act as host. If mobile 2 want to send data here, then mobile 2 need to act as host. So that is a requirement. Okay. So anyway, let's assume the first guy is acting as host and established connection. After that, they'll be able to send the data like this. So irrespective of the method that you're using, in both scenarios, the common thing that happened is establishing connection between both the devices and exchanging of data. That is network. Multiple devices establishing connection with each other and exchanging data. Another example I can say is most of you might be using Wi-Fi at your home to access this class, right? Which means all of you are connected to your Wi-Fi that is at your home. So in most cases, it will either be a modem or it can be a actual router. I've seen those cases as well because some people have like uh, CCTVs and all, and for that purpose, they might have actual routers over there. But still, both of them, these are your access points. Okay. The thing is, you are not the only one connected to that particular Wi-Fi. Maybe your family members will also be connected to the same Wi-Fi to access the internet. Right? Which means you have a common device here to which two or three devices. So it can be a phone, it can be a laptop, can be a PC, right? All these devices are connected to one single modem or one single router. So all these devices are basically connected together to one single device, which basically means that you guys will be able to share data between, like, from this device to this particular device without even going to the internet. The reason is all devices, you have a common point over here. That is a midpoint. Okay. So this particular method of having multiple devices directly connected to something like this, like a router or a modem or etc., can be considered as a network. Okay, this is a small network, something called as SOHO. So in detail about like peer-to-peer and SOHO, we will discuss when we reach the actual topics, like characteristics, physical, logical, all those kind of stuff. We will reach soon. So during that time, I'll explain in detail on peer-to-peer and SOHO and WAN, LAN, MAN, etc., all those kind of stuff. So before that, the one thing that you have to know about a network is that it's just basically multiple devices connected together and is able to exchange data, or resources, or anything like that. Are we clear on the what networking is or what a network is?
Yeah, Kevin, clear.
Okay, thank you. So yes, next we went through common usages. So that includes communication. Okay, fine. Next, what we'll be looking is what are the main components or major components of a particular network. So when it comes to network, you basically have three things. So these are endpoints, intermediary devices, and media. We can say it as four because we have something running in the behind. Let's call it four. We have endpoints, intermediary devices, media, and services. Okay, because services is also an important point. Just write it down. Um, Components. So first one, end points. Okay, so endpoints, that basically means like in context of our networks, these are end user devices. Okay, if you don't get that, what it means? It basically means the devices that you're using in your hand. Okay, a computer you are using to interface with your network. Like if you want to access the internet, you cannot access it from a calculator. You need some kind of end device. So it can be a laptop, it can be a tab, it can be a smartphone, etc. So all these kind of devices are known as endpoint devices. Okay, PCs, laptops, tablets, etc. So all end devices are basically how to say physical hardware. Like all end devices were physical hardware units, and there are today like a lot of end devices that are even virtualized. Like you can even have virtual machines running inside your system, which can be used as a end device. Okay, so to put it simply, any device that you're using to interface with that particular network can be considered as an endpoint device. So that is the first kind of network device. Second one is known as intermediary devices. Okay, so these devices interconnect end devices or interconnect networks. To put it simply, imagine that you have a phone, another phone, like far away, and you want to like establish connection between both of them. You have a router here. Or another like simpler example I can say to you right now is, I mentioned earlier, right, the modem that you have. which basically allows you to communicate with other devices inside your network, like your family's others. If you have another system connected over there, that should be shown over there, right? So all these devices inside a particular network, that will be endpoint devices, and all of them connected together using your modem. So that modem or that particular router can be considered as an intermediary device. Okay, so any device which allows communication between endpoint devices can be considered as an intermediary device. So when it comes to our situation, like for network engineers, the major types of intermediary devices that we will be seeing will be routers and switches. These are the two devices that we are going to see throughout our like studying of CCNA. So first thing is switches. And routers. These two are the major intermediary devices. Step one, switches. What are switches? What are its differences? So the concept of switch is that it allows communication between devices of the same network. Okay. So what it means is you might want to have a lot, you might just want to connect. I'm sorry, is there any doubt?
Can you once again switches what is right? It allows the
Yeah, just starting with switches, no worries. So switches, it allows communication between devices of the same network. And when I'm saying same network, it is basically identified by IP addresses. Okay. If you're having similar series, that means you are on the same network. So here, what basically happens is switches interconnect all the endpoint devices together to form one single network. So if you have a switch here, and let's say you have a PC, you have a phone, you have a tab, you have another PC, etc. If all these devices are directly connected to a switch, this thing will be considered as one network. Okay. Same thing goes for your modem as well. So if you check your modem, all the devices will be directly connected to that particular modem. So that modem is basically having the capabilities of a switch. It is connecting all the devices within one single network. Okay. So to identify all the devices inside your network, I think I can show you something. 1 second, just hold on. CMD, is it not coming up? Okay, there we go. So this is my CMD. So if I want to find out all the devices connected on my network, all I have to do is give a command here to show me all the list of ARP. I give this command, what happens? It shows me all the devices that are correctly connected to my network. So out of this, these you can see, these are all devices of the same network. At the moment, I won't say it because this is my, how to say this, broadcast, not broadcast, multicast address. But basically, it looks like this. When you have multiple devices connected to that, having a similar IP address. So let me see if my phone is connected. It is. So here you can see 192.168.56.255. Similarly, if you check on yours, what you'll be seeing is you'll be able to find out IP addresses with something similar to this. 192.168.1.1, 192.168.1.2, 192.168.1.3, etc., etc., etc. You'll be able to see it over there. That basically means these are the IP addresses of all the different devices that is connected to your Wi-Fi, the one you are currently connected to. Okay. So basically what happens here, data transfer will take place only within the network. If you're having a switch, you'll be able to send data from here to here, and like device to device, as long as all these devices are within one single network.
Sir,
Yes, go ahead.
sir, Wi-Fi is connecting all devices together and all the devices to the broadband or internet also.
Yes, I'm coming to that. I'm talking about the switching capabilities of the Wi-Fi router. After
Sir, I think that, all routers are switches or different.
routers and switches are completely different devices. They are not inclusive of each other.
Yeah, Kevin. I have checked my machine. It has been displayed. What is the type of dynamic and static?
What is the kind? What is the
Types, dynamic and static. There are two types. Is there?
two types of IPs you're asking about?
Types of two types is there, dynamic and static.
Types of what? Because dynamic and static are actually like a common term used for classification of a lot of things. If you're talking about IPs, there is dynamic and static. There,
Yeah,
if you're talking about IPs.
yeah, IP is only which I talking.
Okay. If you're talking about IPs, the concept is like this. You have the ability to specifically provide an IP address to all these devices. If you are manually providing them with these IP addresses, then it is called as static. That is, you might have seen 192.168.2.1, 2.2, 2.3, etc. These are the common types of IP addresses that we have at our home or offices, etc. And you have the option to provide a particular IP address to a particular device. Okay, so I can give this 2.1, I can give this 2.2, 2.3, 2.4, 2.5. That is, if I want to make sure that each one of these devices only uses that particular IP address. Okay, if I do that manually, it is known as static IP addressing. But imagine like a situation where I don't even give a like I don't care about what kind of IP address is being given to this particular devices. In those cases, what I can do is I can do this like set it, configure it in such way that whenever a new device is connected to this particular switch, it is given the IP addresses automatically. That is known as dynamic IP addressing. So let's say this one particular device connected to it the first time. Like this is the first device, it will get 2.1. This is the second device, it will get 2.2. This is the third device, it gets 2.3. Fourth device gets 2.4, etc. Based on who is coming first, they will be provided with the first IP address. So that kind of a methodology is known as dynamic and static IP addressing. Okay, which again is a part we'll discuss in detail when we are talking about different types of IP addresses. So this is IPv4. We'll talk about IP addresses, different types of IP addresses, IP addressing methods, routing, all those concepts. So in detail, we'll discuss during that time. But since you asked about static and dynamic, this is how it is happening. You give it manually, it's static. You let it happen automatically, it is dynamic. Hope that was clear. Okay. So coming back, there was a doubt from somebody else asking about confusion between routers and switches. So I'll just clear it out right now. So I'll explain one by one. So you have switches, you have routers. So modem is not part of any one of this. Okay, it is a completely different device, but it has both switching and routing capabilities. So I just explained it, that particular part to get an idea for you. But let's go with the basics itself. That should be better. So the concept of switches is if you have multiple devices, and you want them to communicate with each other, nothing else. You just want these devices to communicate with each other without interruption. That is where you use switch. Over here, the thing is, each one of these devices will be having same range of IP addresses like 192.168.1.2, 192.168.1.3, 192.168.1.4, 192.168.1.5. All them connected together. And here the concept is these devices will be able to communicate with each other without the requirement of any protocols being said. The only requirement is you physically connect them together to that switch, and automatically they will be able to communicate with each other. You don't have to do any programming over there. No programming, no configuration, nothing. The only thing you have to make sure that is that all of these ports are up, and defaultly they are up. As long as you don't shut it down, it will just start working. So that is the concept of switch. And the thing is, all these networks, all these devices will be part of one single network. And the thing about switch is that switch will be able to connect directly to these end devices. End devices as in your phones, your PCs, your laptops, etc. Okay, so you got an idea about switch. It helps to connect multiple devices within one single network. When you go to routers, the difference is that the routers will not connect directly to these end devices. Instead, what they'll do is they will connect to the switches. So what happens here? Routers helps to connect multiple networks together. So this is one network, right? So just give me a second. This is one network, and you have another network over here. Switch on 92.168.3.1, 3.2, and 192.168.3.3, and another device 192.168.2.4. So these are two completely different networks. So here you can see it is 192.168, 1.4, 1.3, etc. All are 1 dot series. Here they are 3 dot series, 192.168.3, which means both of them are currently two different networks. Okay, if I just try to like connect from this switch to this switch, it will not work. It will not work as in if I send a data from here to here, it will just fail. 1 second. From here to here, if I send something, it will reach this switch and then it will just fail. It will not work. So to make it work, you will have to include an extra component in between, and that is a router. Okay. So now what happens? This switch will be connected to this router. This switch will be connected to this router. And here, this switch will have a gateway. And here, this switch or this network will have a gateway. It's called default gateway in most cases. So now, after all of these are set up, if I send some data from here to here, now what happens? It will come, go to the router, and router will forward it to the switch. Next switch. Okay, and then the switch will forward it to the intended destination. So if you want to transfer data within one network, like from here to here, you just need a switch. If you want to send data from one network to a completely different network, you need a router.
Sir, what is gateway?
Gateway is the route through which you, like your packets or your data, will be able to exit or enter from one network. Like if my data needs to go out of this network, it will be forwarded into this default gateway. And if any packet needs to enter my network, it needs to enter through this default gateway. That is the only route through which my data can exit or enter from that network.
Sir, one doubt, sir.
Go ahead.
Switches will be used in only LAN networks or else in WAN also, sir?
Switches will be used in all the networks. You'll be having switches everywhere because your computer, your devices, and all will be connected to the switches.
Not only in LAN networks, sir?
Not only in LAN, or pretty much all the networks.
Okay.
The main reason is routers will be having very less number of ports, maybe 4 or 6 ports maximum, whereas switches have around 48 ports. Okay. So in those cases,
if you want to connect WAN also, we can connect user switch, sir?
yes. So what you do is for WAN requirement, you connect all your devices to the switches, and from switches, you will take that connection to the router.
Okay, sir.
Okay.
Okay.
And from there, you can establish WAN-based connectivity. Clear? Any doubts on switches and routers? Feel free to ask.
Tell me one thing. Sir, what is the in this scenario? What is the gateway IP in this scenario you are using?
Not sure,
Gateway
Rahul,
IP.
I'm not able to clearly hear you. Can you please add it in the chat, the question?
Yeah, sure.
Please add the question in the chat. I think there is some network issue. I hope it's not from my side. I'm not able to hear that. Please add it in the chat. I will give you the answer right away. Anybody else?
Yeah, Kevin, I have one doubt.
Go ahead. What is the question?
Yeah, in switches, only one type of switches is there, and multiple type of switches is there.
There are multiple types of switches. We will learn about them deeper later. There are basically two types of switches. You'll have layer 2 and layer 3 switches.
Okay. We'll be learning this course.
Yes, yes. Like switch.
Yeah, okay, sure.
Like router in have a session.
Am I audible to you?
Yes, Sriram, go ahead.
Yeah, you mentioned switch. If you defaultly connected to switch, it will transfer the packet data. Then in that case, why is actually configuration is required?
Configuration part is required. Configuration part is required when you want to.
Yeah, Kevin, your voice is echoing for us.
Yeah, for that, please be on mute because like going is when I'm talking and it's been repeating from your side, that happens. Okay, I hope it's clear now. Okay, so the thing is, sorry, what was the question? Just right. Why do we need configuration? So the configuration is required because in switches we are not just limited, like we are not just using it for switching basis. We have a lot of other concepts, other like capabilities inside switches. For example, if you want to let's say add security over there, you have concept of MAC binding. So that is something that you require. Okay, so if you want to do that, that has to be configured because we can't just let anybody come into your network and connect their system into your switch. That should not be permitted. So for those kind of requirements and all, we open switches and configure it over there. Yeah, go ahead. And
Yeah, we
also,
can go. I understood. So basically, if it is connected via Cat6, it will start transferring packets.
Cat 6, Cat 5, all of it is fine.
Okay.
And the thing is, like security and other kind of configurations does happen. Like if you want to add user ID, if you want to add passwords, or if you want to add remote access to those kind of switches, for all these requirements, you need to be like set up configuration over there. So that is the major requirement of configuration when it comes to switches. And also there are other concepts like trunking, VLAN, etc., which again are like extra topics we will be discussing later, not on the first day session. So configuration is okay. So yes, we have another question. What is the gateway IP in this condition? Yes, that is a very good question. The default gateway IP address will always be any IP address from its network. So for example, I hope you can see this layout. So imagine this is my network and I have to add a gateway IP. It should be something from this particular range. So in usually this IP address range will be 192.168.1.1.192.168.1.255. So I can take any IP address within this particular range and add it over there as a default gateway. Similarly, for here, I can use 192.168.3.1 to 3.255. Any IP address within that range, I can give it over here. The only requirement is you have to make sure that IP address is part of that same network. That was a really good question. Although we will be discussing the same thing later when we are actually configuring these networks. Anyway, that's good. That's a good question.
Hello, Kevin. Hello.
So yes, go ahead.
Uh, which cable we use to connect all these devices?
I'm sorry.
I'm asking which cable we use to connect all these devices.
So that depends, like what kind of connection that you have. You have the major two types of connections you use are like straight through cable and crossover cable. Crossover is mainly used when you want to establish connection between same kind of device, like switch to switch, router to router, or PC to router kind of connection. You use straight through, and crossover cables. Sorry, straight through. My bad. I think I mentioned it confusingly. So I'll just recap it. Sorry about that. Mainly, you have straight through and crossover. Straight through is used to connect between layer of devices. That is, for example, like this. When you have from PC to switch or switch to router and all, you can make use of straight through cables. Whereas if you want to establish connection between two switches, or if you want to establish connection between two routers, or between PC directly to router, there you make use of crossover cables. Okay, so these two types of cables that you have. And also you have serial cables, like if you want like long range connectivity between multiple routers, you have serial cables. Not much used nowadays because you have SD WANs, internet and everything. Okay. I hope
Okay,
up to here we are all clear.
Yes, clear, Kevin.
Great. And so that was actually our next topic. Anyway, that got discussed through this. So great. So the next thing I was going to discuss was media. That basically means cables that we are using over here. So this include Ethernet cables, serial links, or even Wi-Fi. So these are the major types of medias that you use when it comes to like enterprise level networking. Okay, so to put it simply, these lines that you're using to establish connection between an endpoint device, an intermediary device, or multiple intermediary devices, basically any devices, you have to establish some kind of connection. It can be Wi-Fi, it can be directly connected like RJ45 based connectivities, Cat6, Cat5e, any of these connectivities, I mean, connecting medias can be used. So wired or wireless, all of this can be considered as like media. So we went through three things mainly now. The first one was endpoint devices, the devices that we use. Second one was intermediary devices, the devices which helps us to connect to other devices, routers, switches, modem, etc. And then finally, media. That was all the other like peripherals that helps us to connect between multiple devices, wireless, wired, any of this can be considered. Even fiber cables, all of this are part of media. Okay. The reason I'm going quickly through this is because here we are just explaining classification. In depth of how we are making use of all these network devices, we have a complete topics for that, like to learn about switches, routers, and all. Okay. So these are the major items that you have to know as components of a network. I hope we are clear up to here. So that's it for today's session. So what we're going to do is any doubts you have, come up and ask. That is for the next 4 to 5 minutes. We can go for the doubts. Can we connect two routers? Yes, definitely. You can connect two, three, four routers, any number of routers you want to connect together. There is no limitations like that over there. Any other questions? If you're not able to like speak up, like sometimes Zoom might have some issue, like your mic might be muted. Feel free to ask it in the chat. Okay, it's also fine. Uh, Can you please explain again difference between crossover and straight through cable? Okay, sure. I haven't explained it actually. The difference between crossover and straight through cable. What I mentioned was you have crossover and straight through cable, which allows communication between devices in a different way. For example, if you want to establish connection from a router to another router, you have to use crossover cable. I'll just mention it like this. That is crossover cable for your reference. The reason here is that each of these ports, they are having specific kind of format or specific kind of pins available. Basically, you'll have 8 pins and they'll be arranged in a particular way. Okay, so to identify what kind of connection is taking place over there, we use these kind of cables. Okay, for straight through cables, the thing is all four will be arranged in the same order. Okay, 1 second. Like A will be pointed to A, B to B, C to C, D to D, etc. They'll be connected in the same order. Whereas, so this is for straight through. Whereas for crossover, there will be slight changes. Again, number of pins will be 8, but first like this, second from here to here, third from here to here. In such way, slight changes will be there for the connectivity. Okay, so to put it simply, whenever you have devices that is going a step up, that is from a particular device like switch to router or computer to switch, you use straight. Whereas if you have from router to router, switch to switch, or computer to router, you use crossover. That's basically how you use it. Does crossover cables and UTT cables are same? Um, let's say they're not exactly the same because UTP is like twisted pair cable, right? So both, to put it simply, both crossover as well as straight through cable are UTP cables. Like its arrangement is the same, just the pins will be different. That is the only difference. To put it simply, crossover and straight through cables are both made up of UTP cables. You just change the arrangement of crimping. That's it. Do we need to know about all the color codings of the cables? For exam purpose, not really. But if you're working in a knock room, it would be helpful, definitely be helpful. Like there can be emergencies when you might have to actually do a kind of crimping or something like that. If that happens, then yes, I would recommend you know about the color codings. And to be honest, it's kind of easy. Like if you're actually working there, you might have actually seen there will be 8 lines within this RJ45 cables. All you have to do is find out that one particular order because that will be repeated inside that particular data center anytime you check. You won't be going for multiple types of crossover cables. Every time it will be in the same order. There was another question in between. Sorry, I did not see that. If we add different gateway in both, our routers can both are communicated. Like you will have to add different gateways. The reason is both of the networks are different networks, right? So each network will have to use their own gateways, which will basically end up being two different gateway IPs. For example, if I have 1 second. I have a network 192.168.1 series here and 192.168.2 series here. Over here, I'd be using 192.168.2.100. And on this, I'll use 192.168.1.100. So obviously, both of them has to be same. If you are giving both of them as same instead of different, like here it will be 2.100, here it will be 1.100. If I'm giving here 1.100 and here 1.100, that will not work. It has to be different. That is a requirement itself. Okay. And it will still work.
So basically, router will have IP assigned to each network.
Yes, exactly. Exactly that. Okay. Any more doubts?
One more doubt. See, if from network A, and assume that there are two network A and B. From network A, I am using the same one IP, and I'm trying to connect to the a device in the another network. Okay,
So,
which is also
like
of
this.
same IP. Like this, yeah. A device in
Okay.
A. So which is also of same IP. So now when a packet
Okay.
is
You're saying
transferred
like
from A to B, yeah.
1.1, and here also you have 192 dot
1.1. Now in this communication, how the router helps in
won't work.
it will be a conflict, IP conflict.
If you are having the same IP, it will not work. The reason is both of has to be same range. Something 2.168.1 dot something. Right.
No, I have both IPs for different IPs for different gateways. Okay.
Here you are saying two.
Yeah. Yeah. In for the
So,
router gateway, I have different IPs, but I have same IP for the devices connecting each other.
so as I said before, this IP and this IP has to be in the same.
Same
If it
range.
is,
Okay.
yeah, same range is a requirement. If not, what happens? It will send it here. It will identify this as the possible gateway and send the packet back. It will not pass through.
Got it.
Does the router need to have an IP address for itself, or it's just half a gateway IPs? For the router itself, you don't have any specific IP address. The router that ISP provides to generate wireless in domestic use, should we also call it a router? No, it is a model. It is just a model, modulator, demodulator. So the thing is, it has routing capabilities, few routing capabilities, because it is able to send your data to the external network, that is internet. So as I mentioned, this model has both routing and switching capabilities, but as you know, it only has 4 ports. So using it on an industrial level will not be possible. It is called a wireless access point. Depending upon your modem's capacity, you can connect up to like 16 to 32 devices onto that. But no, You cannot call it a router per se, but like for like explanation per se or normal communication per se, people do used to call it router because it has these routing capabilities. That's it. Like technically speaking, it's not a router. Okay, so I guess that's it. So anybody joined in late, feel free to check out the recordings. And from tomorrow onwards, please make sure to join in exactly at 8 o'clock. Okay. Just saying this because we will be starting exactly at 8, and I don't want anyone to miss out when we are starting. Okay, then. So that's it. We'll see you all tomorrow. We'll discuss more in depth from tomorrow onwards. Bye, guys. You guys